Right. Hi guys. Here's question 10. No doubt about it, question 10 is a very, very difficult question. But I'm getting increasingly frustrated by your lack of you spotting easy entry points into the question so that you can at least get some of the marks, okay? A is not really that tough a question. It's 3 cos 2x. Well, the very first thing you're going to be doing is it's cos 2x. So you know a formula that helps you change cos 2x. So you should be mucking around with that, okay? But let's just look at the question properly and see how it should be done. We're basically trying to find these points of the x values of those points of intersections, which can be happened by equating the two functions. So we've got this equation here, 3 cos 2x equals 4 minus 11 cos x, okay? Straight away, cos 2x. You know an identity for cos 2x. You should know that cos 2x is equal to 2 cos squared x minus 1. If you don't know that, don't do higher level, okay? We've been through it so many times. Okay? As I've said, making silly mistakes, fine, I get it, it happens. But not being, having that nous to be playful with what's going on, with the things that you've learned, using the tools that you've got, then you're doomed to failure, okay? So come on, get a grip. You see cos 2x, you're going to either need to have that formula, or this formula, which you should have cast to your memory. I mean, it's not in the formula book, but it is sort of in the formula book because you've got the addition formulae, so you can work them out, okay? So, guys, I mean, in that sense, get a grip. Little mistakes, fine, but not being able to get an entry into the question is just not acceptable, okay? So replace cos 2x with 2 cos squared x minus 1, and that is equal to 4 minus 11 cos x. That get you 1 or 2 points. I mean, really, it's not that tough, okay? Now we start to rearrange it. We're going to get 6 cos squared x minus 3 equals 4 minus 11 cosine of x. And what we've got here is a quadratic trigonometric equation. So let's make the right-hand side equal 0. I'll get 6 cos squared x plus 11 cosine x minus 7 equals 0, which can be factored. You should know how to factorize something like this. It will basically end up being 2 cos x minus 1 times 3 cos x plus 7, okay? If you need help with where I got that from, ask, but really, if you can't solve a quadratic, you can't factorize a quadratic equation, something's gone badly wrong, okay? So we can deduce from this that cos x must be equal to 1/2, or cos x must be equal to minus 7 over 3, which is really useful because we can reject this. We can reject it because cos x cannot be more than 1 or less than minus 1. The range is between 1 and minus 1. So we can reject that one. So it leaves me with the only valid equation to solve now, cos x equals 1/2. We need to find cos x equals 1/2 for this domain. Okay, so let's draw my cosine graph, which looks something like this. Okay, that's pi over 2. Pi, 3 pi over 2 and 2 pi, 1 minus 1. So we want 1/2. We should automatically know that one of them is, well, it's 60 degrees, which is pi over 3 radians. And then the other one is here, which is going to be 2 pi minus the same distance, because the graph has symmetry. So it's going to be 2 pi minus pi over 3, which is equal to 5 pi over 3. So there are your two solutions. So we've got pi over 3 and 5 pi over 3. Right, 10b, okay, tough enough question, but entry into the question is not difficult if you've done your work, if you've done your revision. Yet, so many fiddly little bits that you might make a mistake with at some point on the way, but there's no excuse, okay? We've got to find the exact area of the shaded region. Now, even if you got A wrong, and you've got different limits for your integration, you can still pick up all the marks because you get follow through. So failure to do part A does not mean failure to do part B. If you can't do part A, well, make up some points of the limits and then just do that. So you at least pick up some marks for B, okay? You'll get follow through marks. So basically, we want to find this area. What we're going to do is we're going to do the integral of f of x minus g of x with respect to x between those two limits, 5 pi over 3 and pi over 3. Now remember, what you need to do is make sure that this is what you take. You take the red one away from, you take the green one away from the red one. Otherwise, you'll end up with a negative answer. But if you get it wrong and you end up with a negative answer, okay, we'll just take the absolute value of it, okay? It'll be the same answer, just negative. So what we're trying to do is integrate 5 pi over 3 between 3 cos 2x minus 4 plus 11 cosine of x, okay, with respect to x. So pretty easy to integrate. That's going to be 3 over 2 sine 2x minus 4x plus 11 sine x between 5 pi over 3 and pi over 3. Now we need to put in our values. So we're going to get 3 over 2 sine of 10 pi over 3 minus 20 pi over 3 plus 11 sine of 5 pi over 3. Okay, that is with that substitution. Then we've got to take away with the pi over 3. So we're going to get 3 over 2 times sine of 2 pi over 3 minus 4 pi over 3 plus 11 sine of pi over 3. Okay, just need a bit of space here. So just going over here, let's just look at some of the values we need. We need to know sine of pi over 3. Now you should know that. It's root 3 over 2. It's one of the ones I just expect you to know. So say somewhere like this. Okay, that's pi over 3. And hopefully you realise that because this value is pi, 2 pi over 3 will have the same value. So sine of 2 pi over 3 is also equal to root 3 over 2. Then we need sine of 5 pi over 3. So I would say that would be sine of 5 pi over 3. Hang on a minute, just trying to think for a second. I think that will be minus root 3 over 2. Okay, because where would that be? That's pi over 3, 2 pi over 3, 3 pi over 3. It'd be here somewhere. Okay, and 10 pi over 3 will surely be in the same place. So just sort of further along. So sorry, sine of 10 pi over 3 is also minus root 3 over 2. You know, that kind of details, I can forgive you for getting them wrong, but you know, we say entry into the question and following it through. So maybe you don't get the exact right answer, but you pick up a lot of the points. Okay, so let's now look at what that's going to be. That's going to be 3 over 2 times negative root 3 over 2 minus 20 pi over 3 minus 11 root 3 over 2, and then we're going to get minus 3 over root 3 over 4, because sine of 2 pi over 3 is root 3 over 2, minus 4 pi over 3, and then plus 11 root 3 over 2. Sorry, I've kind of run out of space there. Hope that's clear. Okay, so let's just change all that. But I don't want to sort of muck around with it, but I think basically what you'll end up with is minus 16 pi over over 3 plus 25, minus 25 root 3 over 2. Okay, if we allow you to sort of do all the gubbins there. But notice that you basically got a negative answer, and the reason is because this must have been f of x and this one must have been g of x. Okay, so basically did it the wrong way around. So the answer is simply going to be 16 over 3 pi plus 25 over 2 root 3. And, you know, I got confidence that I've got it right because it all sort of matched up with the way that it was expected. Okay? So I hope that makes sense. I say it's tough. It's hard to get all the finicky bits right, but entry into the question shouldn't have been a problem. So you should have picked up quite a few marks. Okay? Right, now we've got C, okay? At the points A and B on the diagram, the gradients of the two graphs are equal. Determine the y-coordinate of A on the graph G. Okay, so this is G of X. This is G of X because that's got A on it, and that's got to be f of x. Okay. So the gradients of the two graphs are equal. So clearly what you're going to need to do is find f dashed x and g dashed x. So again, entry into the question is easy. Okay. What's the differential of 3 cos 2x? Well, that's going to be negative 6 sine 2x. Okay. And differential of 4 minus 11 cos x is going to be positive 11 sine x. So what we're saying is when are these two gradient functions equal to each other? So we've got 11 sine x equals negative 6 sine of 2x. And again, now we know we're going to have to start mucking around with that sine 2x formula. So you're going to get 11 sine x equals minus 12 sine x cos x. Remember that sine 2x equals 2 sine x cos x. Okay? It's obvious that you should have done that, I would hope, by now. Okay? So what we then can do is we can divide both sides of the equation by minus 12x, and you get 11 over minus 12 is equal to cos x. So cos x is equal to 11 over minus 12, or minus 11 over 12, when the two gradients are equal. So if I now want to find the value of a, all I've got to do is replace cos x with negative 11 over 12. So g of x will become 4 minus 11 times 11 over minus 12, because that is what cos x is when the gradients are equal. And so I get 4 minus 121 over negative 12, so that will become positive, which is 48 over 12 plus 121 over 12, which is 169 over 12. Okay, so again, entry into that question is easy if you've done enough revision. When you do, you might make mistakes. I said that's right, but I think you'll find actually once you get good entry into the question, you'll find that it becomes a lot easier and you won't make as many mistakes. Okay, there we go.